All right, so moving on to the next thing, this next category. So this is called view factor rules. So we're going to go through a handful of these. These are now like tools that you can apply, rules that you can follow that maybe once you have something you can derive something else or so on. So the first thing is this something called enclosure. So let's imagine that we have, let me just draw three surfaces. So here's surface 1, here's surface 2, and here is surface 3. 1, 2, 3. All right, so what view factor rule for enclosure says is I'm only looking at the radiation that's inside this, right, inside this triangle. The outer surfaces are excluded from the problem. What this enclosure rule says is if you're a photon and you are emitted from surface 1, what must happen? Well, either you're going to hit surface 2, or you're going to hit surface 3, or I suppose if surface 1 was a weird shape, you could hit surface 1. So those are the three possibilities. By our definition of view factor and by the conservation of energy, right, you can't just lose photons into nothing. So those three scenarios have to add up to 1. So we would say F from 1 to 2 plus F from 1 to 3 plus maybe F from 1 to 1, if that's a possibility. Those three view factors have to add up to 1. All right, this is the enclosure rule. Yeah?
Would you not have to consider reflection or refraction between the surfaces?
Yeah, so this is, the question is, do we have to consider reflection or refraction? You don't for view factors, because remember, for a view factor, the definition is just how much light hits it to begin with. It's not how much is absorbed, it's how much hits it. So the light that's going in that direction would hit it, and then if it's reflected, then you have to deal with it in another way. So if it's reflected, then we might say, okay, it's diffuse in its reflection, therefore we apply the view factor from that surface to the other surface. So you stack up these view factors, and you start getting your result that way. We'll get to that later. But for now, it's only the light that's like hitting the surface, not what's absorbed or passing through it. It may eventually be absorbed or pass through it. Any other questions on that? Okay, so the enclosure rule says this. What are some like changes or limitations to the enclosure rule? Well, we talked about surface 1. So what if we're going from surface 2? Right, this is only the view factors from surface 1. What about surface 2? So let's say F2 to 1, right? F2 to 1 plus F2 to 2 plus F2. So there's like a general formula here. It is, I'm going to take the sum for all index j from 1 to the number of surfaces, n. And we're going to look at fi to j. We're going to sum up all of those. That all has to equal 1. And that has to be true, so this is for all, right? For all. Indices I in the set from 1 to n. Right? So what we're saying here is I'm going to pick an index I, and I'm going to sum over the index j for that index I, and it's going to equal 1 for every single case. So in this case, we'd have three equations, F12, right, and then F21, and then F31, and so on. Okay, so this is the general enclosure rule. You can apply this to solve for stuff. So let's say we knew F1 to 2 and F1 to 3. I can then compute F1 to 1 because I know they all have to sum up to 1. All right, so you'd use this to fill in the gaps in your knowledge. Another example where like you might get a little confused would be, let's say you have this situation. So let's say I have a surface like this, and I have a surface like this. So let's call this surface 1 and surface 2. And then it's open to space over here. Right? So this is open. Can I apply the enclosure rule in this situation?
You could find the open space with another line, right?
Yes, that's right. So the comment was you can if you say, let's call this guy here, let's call this a virtual surface. And I'm going to call that 3. right? Because we're only concerned with what's hitting that surface. Whether it goes through, whether it's reflected, that's not our concern for view factors. So we define this virtual surface. Now I have an enclosure, right? And I can do view factor analysis for this. Yeah, and also in this case, we're going to note that F22, right? That's probably not equal to 0. Where in the other cases it was. So yeah, here we have this virtual surface.
Draw a virtual surface around it.
If it helps you, like the question is whether that's a productive thing to do or not. I mean, so the question was, could you do that for every problem? I mean, yeah, right. So like, let's say you do have an enclosure like this up here. Like, how is a virtual surface going to help in that situation? It's really not. Like, it doesn't add any new information that you don't already have. Here, it's just saying I can sort of cheat by putting this virtual surface. I treat it like I have a view factor to that surface, but I know in effect it's, as the question was asked, like what's happening to it doesn't really matter. It's just going through.